Good day po. Today I will discuss the mass airflow sensor. What is mass airflow sensor? A mass airflow sensor, MAF, is a sensor used to determine the mass flow rate of air entering a fuel-injected internal combustion engine. The mass airflow sensor is one of the key components of an electric fuel injection system in your car. It is installed between the air filter and the intake manifold of the engine. The air mass information is necessary for the engine control unit to balance and deliver the correct fuel mass to the engine and measure the amount of air entering the engine or the air fuel. Air changes its density with temperature and pressure. In automotive application, air density varies with the ambient temperature, altitude, and the use of force induction, which means that mass flow sensors are more appropriate than volumetric flow sensor for determining the quantity of intake air in each cylinder. There are two common types of mass airflow sensors in use on automotive engines. These are the vane meter and the hot wire. Neither design deploys technology that measures air mass directly. However, with additional sensors and inputs, an engine's ECU can determine the mass flow rate of intake air. Both approaches are used almost exclusively on electric fuel injection engines. Both sensor design output a 0.0 to 5.0 volt or a pulse width modulation signal that is proportional to the air mass flow rate, and both sensors have an intake air temperature incorporated into their housings for most post-onboard diagnostics vehicles. Vehicles prior to 1996 could have MAF without an IAT. An example is 1994 Infiniti Q45. When a MAF sensor is used in conjunction with an oxygen sensor, the engine's air-fuel ratio can be controlled very accurately. The MAF sensor provides the open-loop controller predicted airflow information, the measured airflow to the ECU, and the oxygen sensor provides closed-loop feedback in order to make minor corrections to the predicted air mass. Also see manifold absolute pressure sensor. Since around 2012, some MAF sensors include a humidity sensor. Sometimes and most of the time problems of mass airflow sensor. Problems with mass airflow sensors are common in many cars including BMW, GM, Volkswagen, Mazda, Toyota, Nissan, and other brands. The sensor element could get contaminated or damaged. For example, in some Mazda Skyactiv engines, a failed mass airflow sensor could cause the engine to crank but not to start. An improperly installed or collapsed air filter can cause the airflow sensor to fail sooner. Oversoaking a washable air filter can also cause problem with airflow sensor. Symptoms of a bad mass airflow sensor. A contaminated or failed mass airflow sensor cannot measure the amount of airflow correctly. This causes the engine computer to miscalculate the amount of injected fuel. As a result, a bad mass airflow sensor causes various drivability problems, including a no start, stalling, and lack of power and pure acceleration. In addition, a faulty mass airflow sensor might causes the check engine or service engine soon light to come on. A problem with the airflow sensor could also alter the shifting pattern of the automatic transmission. Hot wire sensor MAF. A hot wire mass airflow sensor determines the mass of air flowing into the engine's air intake system. The theory of operation of the hot wire mass airflow sensor is similar to that of the hot wire ammeter. This is achieved by heating a wire suspended in the engine's airstream, like a toaster wire, by applying a constant voltage over the wire. The wire's electrical resistance increases as the wire's temperature increases, which varies the electrical current flowing through the circuit. According to Ohm's law, when air mass flows past the wire cools, decreasing its resistance, which in turn allows more current to flow through the circuit. Since the supply voltage is a constant, as more current flows, the wire's temperature increases until the resistance reaches equilibrium again. The current increase or decrease is proportional to the mass of air flowing past the wire. The integrated electronic circuit converts the proportional measurement into a proportional voltage which is sent to the ECU. If air density increases due to pressure increase or temperature drop, but the air volume remains constant, the denser air will remove more heat from the wire, indicating a higher mass airflow. Unlike the Bain meter paddle sensing element, the hot wire responds directly to air density. These sensors' capabilities are well suited to support the gasoline combustion process, which fundamentally responds to air mass, not air volume. This sensor sometimes employs a mixture screw, but this screw is a fully electronic and uses a variable resistor, especially potentiometer, instead of an air bypass screw. The screw needs more turns to achieve the desired results. A hot wire burn-off cleaning circuit is employed of some of these sensors. A burn-off relay applies a high current through the platinum hot wire after the vehicle is turned off for a second or so, thereby burning or vaporizing any contaminants that have stuck to the platinum hot wire element. The hot film MAF sensor works somewhat similar to the hot wire MAF sensor, but instead it usually outputs frequency signals. This sensor uses a hot film grid instead of a hot wire. It is commonly found in the late 1980s and early 1990s fuel-injected vehicles. The output frequency is directly proportional to the air mass entering the engine. So as mass flow increases, so does frequency. These sensors tend to cause intermittent problems due to the internal electrical failures. The use of an oscilloscope is strongly recommended to check the output frequency of these sensors. Frequency distortion is also common when the sensor starts to fail. Many technicians in the field use a top test with very inclusive results. Not all HFM systems output frequency. In some cases, the sensors works by outputting a regular varying voltage signal. That's all. Thank you.